Selection control. A computer can process a program in the following ways. Sequence, which we've talked about before in our previous lectures. Selectivity, which is what we're going to talk about today. And through repetition, which is what we'll talk about going forward in another lecture. In selection control, we have what are known as logical expressions. An expression evaluates to true or false. Okay? An expression that evaluates to true or false is what's known as a logical expression. One or any non-zero value evaluates to true and can represent true, and then zero is false. This is important to note, especially when we run into perhaps bugs going forward. It's important to note that any non-zero value evaluates to true. We use what are known as relational operators in our logical expressions. Relational operators are also known as binary operators, since they require two operands. For instance, 1 less than 2, 1 and 2 are our operands, less than is our binary operator, our relational operator. In this case, this evaluates to true. 1 is less than 2. All right, some of our relational operators are equals to, not equals to, less than equals, greater than equal to. Logical Boolean operators. You'll find that there are situations when logical expressions are a combination of two or more logical expressions. Okay, we have a logical expression that equals to two or more logical expressions. In those particular cases, logical operators located here take only logical values as operands and yield only logical values as results. So it's important to note here that logical operators here, not and or, take only logical values such as true as operands and yield only logical values as results. Okay, if you look at your tables and you look at your logical operator, for instance, and. Okay, you need to have two logical expressions evaluate here. Here's your logical expression. Evaluate to true and true to be true. So it takes only logical values and yields a logical value. In this case, with the AND logical operator, if you had true and false, it would then be false. And then false is also false. Be familiar with the patterns with the not, and or logical operators. Note that they do have an order of precedence. In this case, in this particular case, it's going to be not will be evaluated first, then and then or, if you see them together on a line. When we're dealing with logical operators, there's also a term called short circuit evaluation. Short circuit evaluation. For instance, in this example, we're going to use OR. In OR table, we have true or true is true. True false is also true. False true is also true. Okay, false false would then be false. So here 1 is less than 2 would be true, or 3 is less than false is also true. However, with a short circuit evaluation, the computer evaluates a logical expression from left to right and stops as soon as the value is known, or as soon as the final value is known. In this case, it stops right here because we're dealing with an OR logical operator in which we know we only need one true for it to be true, regardless of what the second value is here. It stops right here and you get a true. The computer doesn't need to spend time evaluating 3 is less than 4. That is short circuit evaluation. Branch control structures. Branch control structures, what's happening here in this selection control is the first thing with if statements, what we can do is we can have what's known as a one-way selection. A one-way selection. We saw this earlier, if you recall, from my examples with Harry Potter. All right, if a certain expression, logical expression occurs, then this particular statement would execute. All right, if you recall, if Harry was at a certain grade point, average, etc., he would be able to play Quidditch. Okay, if Harry greater than 70 on his average exams, then it would like see out, play Quidditch. Outside of having a one-way selection, you can also have what's known as a two-way selection. If a certain logical expression, then statement, else another statement. That's two-way selection. In other words, if Harry greater than 70, see out, play Quidditch, you can also have else see out, no Quidditch. Right, that's a two-way selection. You can also have multiple selections, a nested if. A nested if has an if-else expression here, and within the else, you can also have an if-else, and then another if-else, etc., etc., etc. To continue on, so to say. Another way of expressing it, instead of actually nesting it with if else, if else, if else, is actually saying if a certain expression, then statement, else if this particular situation, then statement, else if, and then a final else for a final situation, statement. You can also just say if statement, if statement, if statement, so forth, so forth, so forth. All right, those are your various ways of doing if statements. And within each of these statements that you see here, if you needed to, you can actually incorporate what's known as a compound statement. So if you need to execute more than one statement, then you create what's known as a compound statement. Because if you actually said and brought this up here, this cout statement, and just said if and you didn't have an else, it would be actually the same thing as saying if else, because if Harry is greater than 70, cout play Quidditch. If you didn't have that, if Harry was scored a 60, in other words, the C++ would actually automatically kick it down to cout no Quidditch. Okay, and by using a compound statement, if you wanted to include both these lines, you would need to incorporate the brackets. Okay, so one more time. The compiler, or C++, sees if expression statement, in other words, if this is true, it will issue just that one statement. Okay, and then C++ will automatically go to whatever next line there is. Whether it's true or false, it will go to that next line in this particular one-way selection. So be aware, if you ever have a situation where you want more than one statement executed, you'll need to use what's known as a compound statement and include all those statements within these brackets. Let's look at an example. So here we're going to determine the percentage Gryffindor wins a Quidditch match using a simple nested if statement. All right, we're like a Vegas bookie or something like that. Pound include IOStream, remember our preprocessor directive using namespace standard, int main, int broomstick. Okay. Cout, enter the corresponding integer to the broomstick Harry will have access to during the game. Will Harry have access to a Nimbus 2000, Nimbus 2001, or a Firebolt broomstick? Cn broomstick, so the end user will then pick one. Cout and L. So if broomstick, which is an int data type, is equal to 1, remember, the 2 equals 2 sign. All right, this is equality. There's a difference between that and this. This is assignment. This is equality. So if broomstick is equal to 1, this is our logical expression, if we recall that earlier, which produces a logical value, which is either true or false. If the user pressed 1, Gryffindor has at least a 79.9% chance of winning. Else if broomstick 2, Gryffindor has an 89.9%. Else if broomstick 3, Gryffindor has at least a 99.9% chance of winning. And then finally, else, not else if, but else, you entered an incorrect broomstick choice. Okay, then you have system pause, return. Let's go ahead and run this. All right, so let's go for the big dog here. Firebolt. Gryffindor has at least a 99.9% chance of winning. Let's go ahead and test the else right here and enter in 5. You entered in an incorrect broomstick choice.